Today, we're uncovering a fascinating and tragic chapter in medical history, one that directly links a seemingly harmless dietary change to a devastating global epidemic. It's the story of how refining rice inadvertently led to the discovery of vitamins and the birth of modern nutritional science. The disease was beriberi.
It's a really compelling story, Alex. Around the late 19th and early 20th centuries, a mysterious and deadly plague swept across Asia. Patients would start with heavy, weak legs, then severe nerve pain, muscle atrophy. Others experienced extreme swelling, rapid heartbeats, and ultimately died in agony from heart failure. The medical community at the time was terrified, convinced it was some new, dreadful bacterium or virus.
So, they were chasing a pathogen, but you're saying the real culprit wasn't a microbe, a toxin, or even poor sanitation. What was it then?
The true cause of this public health crisis, which killed millions, was a seemingly innocuous change, one that was even seen as a sign of progress and prosperity: the shift to eating whiter, more refined rice. This disease was called beriberi, and its widespread presence in Asian history not only revealed a profound link between refined grains and deadly heart and nerve conditions, but also catalyzed the birth of modern nutritional science.
That's quite a paradox. How could something as simple as polishing rice lead to such a catastrophic outcome? What was happening on the Asian dinner table?
For thousands of years, rice was the staple food across Asia. Before the Industrial Revolution, people primarily processed rice by hand, pounding it to remove the outer husk, leaving brown rice, or, at most, very lightly milled rice. This coarser rice retained the outer layers, the bran and germ. It was rougher in texture and yellower in color, but it was also one of the most important nutritional sources for Asians at the time.
So a relatively unrefined grain was the norm.
What changed?
In the latter half of the 19th century, Western industrial technology arrived in Asia. Steam-powered rice mills were introduced to Japan, China, and Southeast Asia. These machines efficiently and thoroughly removed the bran and germ, producing brilliant white, smooth, soft, and easily digestible, polished rice. Culturally, white rice had long been a luxury, a symbol of purity, wealth, and social status, enjoyed only by royalty or the affluent.
I see. So when this technology made white rice accessible to ordinary people, it became a symbol of improved living standards. Everyone wanted it.
Exactly. But what people didn't realize was that the bran layer, so carelessly stripped away and often fed to pigs or used for fertilizer, contained a substance critical for human life. Later medical documents from the World Health Organization confirmed that this bran layer is rich in vitamin B1, or thiamine. Thiamine is an essential coenzyme in carbohydrate metabolism. Without it, the body can't effectively convert sugars from foods like white rice into energy for cells.
So the body was trying to process all this energy from refined rice, but it lacked the key, the thiamine, to unlock it. What happens when the body is starved of thiamine?
That's where beriberi becomes so dreadful. The brain and heart are the organs with the highest and most stable energy demands. When thiamine deficiency prevents efficient energy conversion, the nervous and cardiovascular systems are the first to collapse. Medically, beriberi manifests in two main forms. Dry beriberi attacks the peripheral nervous system, causing numbness, muscle atrophy, and even paralysis. Wet beriberi affects the cardiovascular system, leading to blood vessel dilation, fluid retention, or edema, and ultimately fatal heart failure due to right ventricular overload.
That's truly a horrifying paradox. People were eating more refined, calorie-dense white rice, yet their bodies were essentially starving at a cellular level. It makes sense then why the incidence of beriberi exploded with the spread of industrial milling.
The impact of beriberi on national power was acutely felt in Japan during the Meiji Restoration. In the early 1880s, nearly a third of the Japanese Navy sailors contracted beriberi annually. Many died, and some warships couldn't even set sail due to a lack of healthy crew.
A military rendered ineffective by a dietary deficiency? How did they address this crisis?
During this critical time, a naval surgeon named Takaki Kanehiro stepped forward. Takaki had studied in London and was influenced by advanced Western epidemiology. Back in Japan, he observed a pattern. Beriberi was rampant among ordinary sailors, but rare among officers. Crucially, it was absent in European prisoners or Western sailors who ate a different diet. Though Takaki didn't know about vitamin B1, he deduced it had to be related to diet.
So he suspected a dietary imbalance, even if he didn't know the exact nutrient involved.
He theorized that the soldier's diet was protein deficient and carbohydrate heavy. To prove it, Takaki conducted a famous controlled experiment in 1884. He arranged for a training ship, the Tsukuba, to follow the same route as a previous ship that had suffered a severe beriberi outbreak. The key difference was the Tsukuba crew's diet. He reduced white rice and enforced the inclusion of barley, meat, and condensed milk to increase protein intake.
What were the results of this experiment?
The results were dramatic. The previous ship saw over half its crew fall ill and dozens die. The Tsukuba, after nearly 10 months at sea, had only a dozen mild cases of beriberi, and those were from sailors who secretly refused the new Western or mixed grain diet. The Japanese Navy quickly adopted the new rations, mixing barley with white rice, and within a few years, beriberi almost vanished from the Navy.
That's a huge success. But you mentioned his explanation was incorrect. How so?
Takaki believed it was due to a lack of protein, not a specific micronutrient. This misunderstanding tragically led the Japanese Army Medical Department, led by figures like the famous writer Mori Ogai, to reject Takaki's theory. They insisted beriberi was caused by an unknown infectious bacterium and continued to supply pure white rice to their soldiers. The consequences were devastating. During the Russo-Japanese War, over 250,000 Japanese army soldiers contracted beriberi, and more than 27,000 died, a number exceeding battlefield fatalities. It's a harsh lesson in how scientific progress can be hindered by stubborn adherence to incorrect theories.
A truly tragic illustration of the human cost of scientific blind spots. So while Takaki solved the problem practically, the underlying mechanism remained a mystery. Where did the true scientific breakthrough come from?
Well, Japan debated. A crucial scientific breakthrough was brewing in the Dutch East Indies, now Indonesia. The ruling Dutch colonial government faced similar beriberi epidemics in its army and prisons. A medical commission was sent to Batavia, and one Dutch physician, Christian Eijkman, stayed behind to continue research.
He must have started with the prevailing germ theory like everyone else.
Absolutely. It was the era of Pasteur and Koch, with new bacteria being discovered. Eijkman initially tried to isolate a causative bacterium from beriberi patients and inject it into chickens to create an animal model. Months passed with no progress. Then, one day, his laboratory chickens suddenly became ill, showing weakness, inability to stand, and neurological twitching, symptoms strikingly similar to human beriberi.
It sounds like he finally induced the infection, as he intended.
He thought so too. But strangely, after a few weeks, these sick chickens miraculously recovered en masse. This collective pattern of illness and recovery didn't fit the typical infectious disease model. Eijkman, like a detective, investigated the chickens' living conditions before and after their illness. The Nobel Prize Committee later recorded this famous moment. Eijkman discovered a critical dietary change.
A dietary change? What was it?
The lab's cook, to save money, had been feeding the chickens leftover polished rice from the military hospital kitchen. This period of eating white rice perfectly coincided with the chicken's neurological outbreak. Later, that cook was replaced, and the new cook, thinking it wasteful to feed military-grade white rice to chickens, switched to cheaper, unpolished brown rice bought from the market. Miraculously, the chicken's neurological symptoms disappeared.
That's an incredible accidental discovery. So it wasn't a bacteria causing the illness, but the absence of something.
Exactly. This accidental finding shocked Eijkman.
He conducted rigorous controlled experiments, which clearly showed that chickens fed pure white rice became ill, while those fed brown rice or white rice supplemented with bran remained healthy. Eichmann reached a revolutionary conclusion. Beriberi wasn't caused by bacteria, but by the lack of some essential substance in white rice, or perhaps a toxin in white rice with an antidote in the bran.
And his colleague refined this idea further?
Yes. Another Dutch physician, Gerrit Grijns, clarified that it wasn't a toxin issue, but rather that white rice processing removed a nutrient vital for the nervous system. This was the first time in human medical history that the concept of nutritional deficiency disease was explicitly articulated. For this pioneering work, which opened the door to modern nutritional science, Eichmann was awarded the Nobel Prize in Physiology or Medicine in 1929.
From Takaki's barley experiment to Eichmann's sick chickens, this quest for Beriberi's cause ultimately led to the Polish biochemist Casimir Funk successfully extracting this anti-beriberi substance from rice bran in 1912. He named this life-sustaining amine vitamin, which is now the word we use today. So beriberi didn't just lead to the discovery of B1, it gave birth to vitamin science itself.
It fundamentally changed our understanding of food. We began to realize that food isn't just fuel. It contains tiny but indispensable chemical substances that maintain our body's intricate machinery at a microscopic level. But the history of beriberi isn't just a scientific triumph. It's a mirror reflecting human behavior and cultural blind spots.
It's a sobering thought that this large-scale disaster, which claimed millions of lives, was entirely self-inflicted. It was a product of modernization, industrial technology, and a seemingly irrational cultural preference for purity and whiteness. We stripped away the most nutritious part of grains for refined taste and social status, then suffered terribly from the lack of those nutrients.
It's a powerful irony, and this paradoxical phenomenon hasn't disappeared in modern society. While severe beriberi is rare in Asia today, thanks to diverse food sources and mandated B vitamin fortification in refined flours and rice in many countries, the link between refined grains and modern lifestyle diseases remains strong. Obesity, type 2 diabetes, and cardiovascular diseases are all largely connected to our excessive consumption of refined carbohydrates that lack fiber and essential nutrients.
So the lessons of history echo on our plates today. We have unprecedented food processing technology, making food sweeter, softer, and last longer. But in doing so, are we, like those 19th century people who discarded life-saving rice bran, still throwing away the elements truly essential for health?
Beriberi's story reminds us that medical and health answers aren't always in high-tech labs or magical new drugs. Sometimes the most lethal threats come from everyday changes we take for granted, and the cure might be hidden in things we consider coarse, cheap, and easily discarded. As we pursue more refined and convenient lifestyles, maintaining respect for nature's original design might be the most important lesson we learn from this painful history.
If this discussion about the intersection of diet, medicine, and history changed how you look at everyday food, share this episode with anyone interested in the history of nutrition or curious about the stories behind our meals.